so we're going to look at problems 10, 11, and 12 now. We need to come up with a quadratic equation that has each of the following types of solutions. So in number 10, they're asking for two real solutions. So I picked a parabola that's crossing the x-axis at -2 and -3. So think about this. That means that my x has to be equal to -3 and or x equals -2. So going backwards in the process then, well then I know this would be +3 and +3. So now I have x plus 3 equals 0 and or x plus 2 equals 0. So I know then that my quadratic is going to be an x plus 3 and an x plus 2 equal to 0. And if I multiply this, I'm going to get x squared plus 5x plus 6 equals 0. Boom. There is a quadratic with two real solutions. Now let's follow that line of logic and see if we can do it for number 11 as well. So on number 11, they want two complex conjugate solutions. Two complex conjugate solutions. Alright, so let's see. Well, you know, if that's the case, then we're going to have an I. So let's see here. Let's draw a graph. So let's say that I wanted to create a parabola that was going up like so, and that I chose a vertex right here of this being -10, 4. Alright, how could I write a quadratic that would take on these characteristics where it would be going up and that the vertex would be a minimum and that it also would be have no real zeros? Well, the first thing I would do is I would use the fact that remember, the vertex is h comma k, and h is gotten by -b over 2a. Alright, so if I know my vertex has an x coordinate of -10, let's do a substitution and replace h with -10. -10 is equal to -b over 2a. So now I can think of different combinations for my b and a that would give me this result. If I let a be 1, let's make it simple. Let a be 1. Let a equal 1. In order to make this ratio come out to be -10, then b is going to have to be 20. So then b equals 20. So at this point I now have an equation that looks like this. I have 1x squared plus 20x plus some c. Now remember, 4, so think about this, that this line right here crosses the y-axis at 4. This line represents y equals 4. So we're going to say this is equal to 4. Now, I know my x is -10, so let's do a substitution in for that. So I'm going to go 1 times -10 squared plus 20 times -10 plus c equals 4. this becomes 100. This becomes minus 200 plus c equals 4. This becomes negative 100 plus c equals 4. Therefore, c has to be equal to 104. C has to be equal to 104. So, if A is 1, B is 20, C is 104, therefore my equation, A equation that would fit these parameters would be 1x squared plus 20x plus 104 equals 0. That would be a possibility. That would be something that would fit and would wind up having two complex conjugate solutions. Okay, and again, to look at how I did this, I picked my vertex, I picked which way this was going, this being, in this case, the parabola is going up. I chose the vertex, found the h to be this. I chose my a and b based on the relationship of this ratio that would cause this to go to negative 10, and then set the quadratic with my a and b. C was still my unknown. I knew that this is crossing, that the intersection between this horizontal line crossing the y-axis at 4 and the parabola would give me this equation. Substitute back in the x-coordinate, or my h of my vertex, to give me one quantity remaining, which would be c. So if I were to plug this into my graphing calculator, I would indeed get a picture that looks very similar to what you see in the picture on my drawn graph.